Making the right engineering choices in today's wide landscape of cloud technologies is hard. Predicting the future in order to invest in companies in this space has the same level of complexity. The cost of cloud computing is going down, but the volume of total required space and processing power is going up. The open source community is growing and improving, but people are increasingly willing to buy software that will save them time. There are many countervailing trends. Capital is flowing into Silicon Valley at a faster rate than can be sensibly absorbed by the number of quality companies that exist. A decent product won't have trouble raising money, but a decent investor has to choose wisely among the huge selection of available opportunities. Lenny Pruss works at Amplify Partners, where he is currently focused on the cloud-native space. In this episode, we talk about what cloud-native means and how to navigate the complex landscape, whether you are an engineer or an investor. I enjoyed this conversation a lot, and I want to thank Tom Tungus for introducing me to Lenny. Tom's episode was a while ago. We talked about his book, Winning with Data, and if you like this episode, I encourage you to check out that one. Life is too short to have a job that you don't enjoy. If you don't like your job, go to hired.com/sedaily. Hired makes finding a new job enjoyable, and Hired will connect you with a talent advocate that will walk you through the process of finding a better job. It's like a personal concierge for finding a job. Maybe you want more flexible hours or more money or remote work. Maybe you want to work at Facebook or Uber or Stripe or some of the other top companies that are desperately looking for engineers on Hired. You deserve a job that you enjoy because you're someone who spends their spare time listening to a software engineering podcast. Clearly, you're passionate about software, so it's definitely possible to find a job that you enjoy. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $1,000 signing bonus from Hired when you find that great job that gives you respect and salary that you deserve as a great engineer. I love Hired because it puts more power in the hands of engineers. Go to hired.com/sedaily to get advantage of that special offer. And thanks to Hired for being a continued longtime sponsor of Software Engineering Daily. Lenny Pruss is an investor with Amplify Partners. Lenny, welcome to Software Engineering Daily.
Thanks so much for having me, Jeff.
You've been studying the cloud-native space and writing about it, trying to figure out what investments to make, what technologies are getting traction. What does the term cloud-native mean?
Yeah, so I think there's a couple things to unpack. I think starting at the highest level, cloud-native is really an architectural paradigm, a software architectural paradigm where that describes that, how apps are built as resilient distributed systems that, scale to meet the demands of millions or tens of millions of users. This paradigm was really sort of informed and inspired by, warehouse scale computing that takes place inside of organizations like Facebook and Google. And then, when you think about what a cloud native app is, there's sort of this technical definition that people have globbed onto where, it's microservices oriented. So microservices, that being that these applications are composed of sort of discrete, loosely coupled services. These applications then are dynamically scheduled and orchestrated, and then the container is the functional unit. So that's sort of the technical definition. And then, there's this notion of the cloud native stack that we've been delving into, and that's really sort of the infrastructure and tools that go into, building, deploying, and managing these applications. So,
and one way that you frame this cloud-native architecture is in terms of these layers. Maybe you could describe the layers of the cloud-native architecture.
Sure thing. So when we talk about the layers, we're really talking about all the components that go into running a production-grade distributed system. When you're running an application that lives as a monolithic code base on a single server, that's one thing. But running decentralized apps that you're trying to scale to millions of end users, that brings about unprecedented levels of complexity. And so the tools needed to build these apps and the components in the stack needed to support them are different. Just a few years ago, nobody really talked about things like service discovery or scheduling. If anything, these were elements confined to the world of high performance parallel computing. Now these are household tools that are part of everyone's lexicon, anyone who's trying to build microservices. And to provide a little backstory, when Docker came out in 2013, and as this market started to mature, I started mapping all these projects and all these companies to try to make some order out of it. And so I put a bunch of these projects in a stack to try to visualize how everything fit together, and kept tabs on this ecosystem. Then last year, we teamed up with the Cloud Native Computing Foundation and the Technical Oversight Committee, which at the time itself was voting on the CNCF reference architecture. And the goal of this was to really provide a more definitive taxonomy and reference design that would detail many of the prevailing projects and companies that make up this ecosystem and make some order out of the chaos, just to give folks who are entering the ecosystem or actually or practitioners who are building these systems a better sense of how everything mapped together. Ultimately, that work was represented by the Cloud Native Landscape, which was a document that we released at last year's KubeCon in Seattle. Now to get back to the layers, again, these are loose definitions, and all of this relates to the elements that are needed to run a distributed systems. But if we want to walk through the stack, at the bottom is the infrastructure layer, and obviously this relates to the physical and or virtual compute network and storage resources that serve as the building blocks for any application. Moving up, we've got the provisioning layer, and this represents sort of the tools needed to stand up and manage those infrastructure resources. These are tools that are things like Terraform, Puppet, Chef, and also things that are necessary to secure this infrastructure. Moving up, there's the runtime layer, and that's where the container engine, most notably Docker, lives. And that's responsible for operating system level virtualization. In this layer, you tend to include also things like cloud native storage and network resources that interface with the container engine and extend down into the infrastructure layer. Then you get into the orchestration layer, which is really the management plane. Here you have tools like Kubernetes, Docker Swarm, Mesos, as well as elements like service discovery and service management. And most basically, this layer really plays the role of a conductor and an orchestra. It takes all the underlying resources and services and composes them into a logical application and serves that to your end users. Finally, above that is what we call the application definition and deployment layer. And these are really a bevy of tools, or a bunch of different tools that are responsible for that developers use really to build their apps and then to deploy them. So things like languages and frameworks, CI/CD platforms, source code management, and the like. The important thing to note about all of this is that this strives to be canonical, if not an overly simplistic representation. In real life, elements of all these layers extend up and down, and at the end of the day, this is really sort of a three-dimensional, dynamic, living, breathing organism.
Absolutely, and I think a lot of this has basically been driven by this movement towards cloud infrastructure, and the shift towards cloud infrastructure was such a fundamental change that it led to all of these other advancements that improve the efficiency of our stack ultimately. They improve the leverage that an individual programmer has. The cost, in some ways, is the complexity, although I guess there was just perhaps equal complexity in an on-premise setup 20 years ago, but the complexity manifested in different ways. Now the complexity manifests in ways like you've got so many layers like you just described, and you've also got the observability question. You have an entire side of your application devoted to understanding what is going on in your application, and there are a million products around this. I'm sure we'll get into that. What are the canonical problems that developers are dealing with in the cloud native ecosystem? Obviously, one way to look at all of these things is that they are creating opportunities for more leverage, but another way of looking at it is, well, especially from an investment point of view, is as we get these increasing layers that are adding leverage, there are also new problems that crop up. From an investor point of view, I'm sure some of those look like opportunities. So what are those canonical problems?
Of course, any new platform shift, a customer's problems or pain points are really a startup's opportunities. So the way I've seen this ecosystem evolve was, Docker came along and provided this really neat, lightweight abstraction for a developer to take their application, wrap it up with all of its dependencies, and be able to deploy it on any Linux-based server. So you had developers everywhere using this cool new tool called Docker as a universal package manager. And then they started to deploy Docker, and there were all these coordination challenges around service registration, discovery, networking, orchestration, really around challenges of now that you've got your app or these independent little microservices, how do you manage them at scale? How do you manage them across hosts? How do you do networking across hosts? The canonical problems then were as simple as how do I make a couple of these services running on two different nodes really talk to each other and turn those two services into a logical app. More complex issues around them were how do I manage state in this environment? What does networking look like, again, between hosts, between data centers? And so what you had was a bunch of projects and companies that formed to help solve around some of these day zero problems of how do I actually create an app and manage it. And because of that, it was sort of a gold rush to take advantage of this new platform shift, and there were seemingly millions of permutations of stacks that you could run for your containerized app. Luckily, over the last few years, we've seen some standardization. At very least, Docker has unquestionably emerged. The package format, you've got Kubernetes, Mesos, and Swarm as the orchestrators of choice. Consul or etcd for service discovery. And so now that the building blocks are more set, the challenge is still around making all these different systems play nice together. Over and over again, you hear things as simple as taking a Docker compose file from the developer terminal and turning that into a running container in production is a broken workflow. And so there's no doubt that the community, the open source community, will continue to work to solve some of these problems. I'll say, most of the juicy problems have been solved, and most of the major platforms have been won. The one area I'm still excited about is solving multi-cloud. There needs to be a platform that gives companies the ability to deploy across clouds, across platforms, and then manage and provide visibility into the health of those applications. Things like Kubernetes are an enabler of this, and they'll serve as sort of a distributed runtime, a distributed fabric to deploy applications across clouds. But then to actually gain visibility and into the health of those systems is something that I think is really missing.
Yeah, you mentioned going from that place where you're putting out fires constantly to having more stable infrastructure and having this place where companies can experiment rapidly, the employees feel comfortable, they have a lot of leverage, things are decoupled so they can roll out changes aggressively. I remember having a conversation like this last week. I interviewed Matt Klein, who works on Envoy, which is a Lyft application proxy, and he talked about how when he arrived at Lyft, people were afraid to change code because they were just afraid that this was going to take down the entire system. They didn't feel like there was enough observability. They didn't feel like there was enough safety in a deployment. And over time, as particularly regarding Envoy, as he rolled that out, people got more comfortable, and it was a massive advantage. So I guess I'll use that to segue. If someone comes to you with an open source tool with traction, like let's take Envoy, for example, because we just did a show on it. It'll probably air before this episode airs. When you look at something like Envoy, it's this application proxy. It sits on all your servers in an infrastructure, and it proxies requests so that you have a unified communication tool. It gives you a unified load balancing layer. If somebody came to you with an open source tool that was like, this has some traction, or this is deployed at a company, is that traction enough of a reason to invest, or do you have to be able to see further down the line?
Look, I think this gets into a lot of the questions around open source in general. And it's funny, this is timely because we're looking at a similar project right now that's, born inside of one of these web scale properties. And it's been battle tested. There are people using it. There are people excited about it. But at the end of the day, though, the goal with any technology, even though the world that we're living in is vastly different than it was maybe, 10, 15 years ago, the same rules apply. The goal with any technology is to become a standard. And once you become a standard, you have these value chains that coalesce around these standards. And once you're basically, once you've codified your place in the stack, then there's a real unique opportunity to start extracting value. And that's how, really big, meaningful infrastructure companies are born. So, green shoots of traction and adoption are a fantastic place to start. But the larger macro question is really about, how applicable, how universal is the value prop, and is this something that's universal? And not only is it universal, but is it, it's this classic, is it 10x better than the substitute? Because in an open source world, while anyone can take your code and improve on it, and so, you have to be, especially as an investor, you have to be very very careful or tread lightly in a sense of not giving into this incrementalism. And what might be good today, will it persist over time, and will the value remain of what you're doing? So, I guess putting on the investor hat, whenever you're looking at a technology like Envoy, it's, what is its role today? What does the stack look like tomorrow? And is this something that becomes more valuable over time? How could it basically ward off either homegrown solutions, different open source platforms? What does the stack really look like tomorrow? So these are all questions that we're wrestling with as investors, and quite frankly makes infrastructure investing a bit of a challenge today.
Well, absolutely. And so one of the ways that you just framed this is how much surface area does this open source tool eventually take up? And because obviously the more surface area it takes up, you're building a market with a value of X and trying to capture some percentage of that market. That's the adage for building platforms. And, one analogy I think of here is Docker. And Docker is obviously become this fundamental technology to application development. And yet it seems like the business model is still up in the air. As far as I understand the economics of the company, the burn rate, they still have plenty of time. There's no threat. But, I was at DockerCon, and I remember having a lot of conversations with people like, is Docker going to get acquired by Microsoft? Like, what is there? It's certainly not obvious where they're going. And are they going to, like, can Docker be obviated? Is the real platform Kubernetes? Mm-hmm. And so it's interesting to look at that, and especially I contrast that with more narrow investments that you could make, like where you're investing in maybe a very specific observability tool. Like if some company came to you and said, okay, we're doing distributed tracing, we're going to master distributed tracing, or even like we're going to master Java distributed tracing, like something very narrow and specific. In some sense, that seems like a safer bet, but maybe that's less of a venture investment. So I don't know, like where do you see that sort of like narrowness versus platformness playing into what makes a plausible venture investment?
Absolutely. So this is the fundamental question I think facing most infrastructure investors is, solve a very acute, narrow problem, basically ingrain yourself in the stack and then expand. The question becomes, when you position yourself in the stack, where are you more ripe to expand into different adjacencies? So again, let's take the distributed tracing example. Distributed tracing could be a potentially an incredibly strategic area because you're instrumenting every part of the stack. So while at Redpoint we actually had a chance to invest and work with a distributed tracing company, they're still in stealth. But once you're in the critical path, there's all sorts of data you're extracting, whether it's sort of in-process logs, network calls, that allow you to build a sort of comprehensive view of an application and its behavior and all the underlying systems. So with that example, you eventually start subsuming multiple systems that you're using for observability, whether that's, your traditional infrastructure monitoring, whether that's your APM tool, whether that's actual logging. So that is a potentially incredibly strategic area because it's all about where you're deployed and what information and what data you have access to. Again, in many ways, infrastructure investing is no different than a lot of other investing where data is critical and data is the critical asset. What is your proprietary data source and what can you glean from that and what value can you deliver to the end user? That's the critical question. When you're looking down in the stack at more traditional utilities, same question. The reason past companies have struggled, I'd say, is because, infrastructure vendors can subsidize the cost of the sort of management and deployment tooling and deliver a similar experience. So generally value is eaten from the bottom up. So this question is absolutely central to what we look at when we're investing in companies. And so I'd hesitate to say we have an answer, but it's central to a company's attractiveness when they have an easy path to extend either up and down or east-west in the stack.
Are you ready to build a stunning new website? With Wix.com, you can easily create a professional online presence for you and your clients. It's easy. Choose from hundreds of beautiful, designer-made templates. Use the drag-and-drop editor to customize anything and everything. Add your text, images, videos, and more. Wix makes it easy to get your stunning website looking exactly the way that you want. Plus, your site is mobile optimized, so you'll look amazing on any device. Whatever you need a website for, Wix has you covered. The possibilities are endless. So showcase your talents. Start that dev blog detailing your latest projects. Grow your business and network with Wix apps that are designed to work seamlessly with your site. Or simply explore and share new ideas. You decide. Over 100 million people choose Wix to create their website. What are you waiting for? Make yours happen today. It's easy and free. Just go to Wix.com, that's Wix.com, and create your stunning website today. Yeah, makes sense. What about the Rethink DB example that happened recently? So this was an open source business model that was a developer tool. It didn't work out. It had some traction in the developer community, but the business model didn't really pan out. I don't know if you read that post-mortem, but what were the lessons that you take from the Rethink DB situation?
So when it comes to the question of open source and open source business models, I'm not quite a contrarian, but I am more optimistic than some VCs who just have given up on it and refuse to touch it. My philosophy is that you can be a successful, thriving open source company. It just, the time horizon is elongated, and that these businesses through their growth curve are much more fragile. And so my hypothesis and thesis is that it's not that open source can't succeed, it's that it hasn't really been done right for several years. And so, to illustrate some of these challenges, I'm working on a new analogy. So bear with me a little bit. Tell me if I'm crazy. But the analogy is hunting versus farming. So in the days of proprietary software, once you had a new technology and you found product market fit, it's really all about going out and finding your customers as fast as you can and growing as quickly as possible. And as long as the market doesn't dry up, so long as there's buffalo, and as long as a new technology doesn't come to displace you, so long as a better hunter doesn't come on your territory, you're going to be fat and happy for a while. The point being, if you've got a great product and an eager market, you could extract value and grow really, really quickly. And we saw a number of companies that did this really well through the course of the 90s and early 2000s. With open source, however, it's a much more delicate song and dance. And your success, the problem is, of course, is your success isn't solely contingent on the merit of your capabilities as a product. Or to finish the analogy, your capabilities as a farmer. So let's assume you're a great farmer. You've got, and everything goes well in your planting cycle. You use your seeds the right way, use your fertilizer, the weather's perfect. Even then, it's going to be months before you can reap the rewards of what you sow. But then there's also all these elements out of your control, weather, birds. I really don't know what I'm talking about at this point. But the point of all this is building, just like farming and raising a successful crop, building an open source company is really about fostering ecosystem and nurturing your seeds. And so in that process of actually building an open source company, there are so many things that are outside of your control that directly impacts your viability as a project or technology or directly a business. So people can take your code base and they can fork it, they can make slightly better, and they can capitalize your market. A cloud vendor can take your software and deliver it as a managed service, and you're hosed. So to me, what this points to is that it's not that these businesses can't succeed, because there's clearly been examples of successful open source companies. It's that a lot of the time these businesses take much longer, and they're much more fragile. So in these businesses, I guess what I look for is, is there community, and are the vendors, are they building trust? The key with open source, relates back to this idea of becoming a standard. And so, you have to believe that once adoption is universal and you've ingrained yourself in the stack, or you support some unique workflow, then you could start thinking about monetizing. And by the way, monetizing doesn't mean delivering some sort of delivering something that's not out of the open source, but it really relates to delivering some truly differentiated developer or ops experience that no one in the ecosystem can easily replicate. So there are a few examples of this. I think HashiCorp is definitely one. Elastic is another. There's certainly few and far between. But again, open source as a business model has really become sort of the status quo only in the last sort of half decade. So the proof is yet to be the proof of the viability of these businesses is really yet to be determined.
So I can think of a couple counterexamples to the long lead time to profitability, though, because Like I think about Cloudera or Red Hat, basically, where you have the model of we're basically going to have a consulting shop that is an incubator for a open source platform that is so complex to set up that you need consultants for it. So they have this there's this nice ecosystem that they can develop within a company where they have consultants, they have people working on the open source projects, and there's a nice relationship there. I don't know, does that still seem like a plausible? I guess that's, maybe it's been a while since we've seen. Well, I think we still see some companies in that mold, right?
In terms of the Cloudera model, where you're sort of developing on the core, but also have an army of consultants and sales engineers.
Is that an appealing model as an investor, or is that too much? Like I guess the consultant churn is that makes it some execution risk.
I think it's a challenging model, and I think it speaks to the fact that it's Cloudera was founded in 2008. It's been almost 10 years. They are without a doubt sort of the dominant force in open source analytics infrastructure. It's certainly a capital intensive model. It runs counter to the traditional software build business where it's high gross margin,
right?
High gross margin, high contribution margin. But there's an argument to be made where you can build a business with sort of technical domain expertise, where you are the sort of trusted infrastructure vendor. You get to not only sort of reap the benefits of the ecosystem you own, which might be sort of HDFS and the Hadoop ecosystem, but also other things that come around. So if you've watched what happened with Spark, Cloudera's managed to co-opt a bunch of the value creation with Spark just simply because, hey, this is open source. We already have account control. We're going to come in and we're going to set up a Spark cluster for you and also own all the training and support that comes around with it. So again, this is another element that makes open source much more difficult is when you have a company of Cloudera's scale that has this account control, that's built trust with traditional enterprises, it becomes much more difficult to dislodge. Now that begs the question, can there be another Cloudera? I guess if there's a technology that comes around that's as transformational as HDFS, where the economies of learning are so steep where they can't encroach, then maybe.
So Cloudera model sounds like you get kind of Accenture margins where you have the army of consultants that if they were just consultants on their own, they wouldn't be able to make as much as they can at Cloudera, where they are Cloudera, engineers, basically consultants. And then you also outlined how there's this opportunistic business opportunity where you can upsell people as the stack changes. It changes from Hadoop to Spark. Oops, you want Spark? Well, it's just going to cost you a little bit. And I mean, when I think about the platforms potentially that could mirror that sort of evolution, I think of Kubernetes. I think of TensorFlow. These are complex. I mean, they're complex in a certain way. They're complex enough that I can imagine needing, or at least wanting, an army of consultants. And there are a lot of Kubernetes as a consultancy companies coming around, or we've got a fork of Kubernetes and it's got some proprietary layers on top of it. Do you find these businesses plausible? These are things like Rancher Labs, Apprenda is sort of doing this. Do you see these companies as analogs to the Cloudera type of companies?
Not particularly. I think so. I guess, when you think about the companies you mentioned, there's sort of two schools of thought. We're going to come in and we're going to help you. We're going to support and service open source Kubernetes, and we're going to take advantage of all the features that the open source community is adding on, and we're going to use the rate of innovation as a benefit and sort of draft off that and build a bunch of tooling and support and basically plug in the gaps maybe in the management layer where the core Kubernetes community isn't keeping up. And then there's another school of thought where, hey, there's a bunch of enterprise features where core Kubernetes has missed the boat, and we're going to fork Kubernetes and we're going to have our own distribution. And that to me is a challenging model in a cresting market where the rate of innovation is really, really fast. In general, when you have a market and a product or a platform that's developing as quickly as Kubernetes, I think standing in front of that tidal wave is really, really challenging. And instead of basically forking that product and putting your own spin on it, you'd be much better served building out the supporting ecosystem for that. Whether that's secrets management or some
this is
sort
like
of
Weave.
Yeah, exactly. So I think those guys have a fundamental appreciation for open source done right and are basically building the tools and services to help you as a Kubernetes adopter be successful. And so I think that to me is the right strategy. Whether that's going to create a company of venture scale return remains to be seen. I think that's challenging, but I think it's probably in terms of sort of, long-term viability, that's probably a safer bet than working the main project and trying to live off that, unless you're doing something that's so different and so value additive, again, this sort of 10x nature, then I think it's challenging.
Well, these companies like Weave, for example, who are focused on Kubernetes tooling, I think, basically, like networking around Kubernetes and perhaps other container orchestration, maybe Mesos also, I think, and visibility. An advantage of those companies is they get to sort of ride alongside the Kubernetes ecosystem, but they're not exposed to the risk of building directly on top of the Kubernetes ecosystem, like breaking changes to whatever they have. And also, they get the kind of opportunism that you mentioned earlier with Cloudera, where if they see a market opportunity, they have such intense domain expertise that they can perhaps seize that opportunity, and then maybe their business delivers venture returns. So I want to shift this conversation. I want to talk about the infrastructure layer, because this is the thing that is the most exciting to me right now, mainly just because we have Amazon Web Services, we have Google Cloud Platform, Microsoft, IBM, DigitalOcean. I mean, this layer is exciting for a number of different reasons, but the one that I always think of is how it brings out the philosophical differences between Amazon and Google, which are the market leaders. We're seeing this. I mean, the market is evolving so interestingly because, Google and Amazon are kind of, they're different. I mean, they're offering the same, there's overlap, but they are offering very differentiated product philosophies. And I mean, it sort of resists any particular analogy, but, the closest analogy might be, it's like Microsoft and Apple or something.
Right. And, that's actually a very apt analogy. The best explanation I've heard about this, and to give someone, as weird as it might be, someone I've never met, but someone who I respect a ton, Ben Thompson, a shout out on this, was right after Amazon reInvent. He had a great podcast around how do you differentiate between AWS and GCP, Google Cloud Platform. Mm-hmm. And the fundamental difference was Amazon, in its essence, is a services company. Google, in its essence, is a product company. And the way they expose their cloud offerings mirror that. So what AWS does is they'll have primitives for compute, network storage, databases, even higher order services around sort of real-time streaming. They will always be exposed as sort of a standalone primitive that you can then go and build on top of. And they'll be about 75, 80% complete. And then it's on you to sort of integrate it in your stack and build on it. Google, in its essence, is a product company. And so the way you interact with their services is through sort of a defined API that they control and they specify. And you consume those resources, like compute becomes an API resource, storage, network, all these things are exposed through almost like a productized layer. So in that sense, that analogy holds pretty closely in the sense that one is a platform, one is a product. And, I think there's plenty of room in the market for both to exist. It's just a matter of what your developers or what your ops team, I guess, in some instances is used to and what they're trained on. Most of the market, because Amazon created it starting really in earnest in 2006, they were schooled on this stuff. And so this notion of very basic, boring primitives that you can build on top of holds. But more and more, we're seeing companies gravitate to this sort of fully baked, productized version of what Google's offering. And so, especially with as much cloud as they hold in areas like machine learning, there's an opportunity for Google to meaningfully win customers over.
I agree with that. I agree with most of that. I do think Ben Thompson is, so I love Ben Thompson. I love his podcast. I do think he gets wrapped up into the narratives of the companies a little more than is apt. I think, if you pigeonhole Amazon as a services the thing is, these things are not mutually exclusive. Amazon could Amazon's, building out serverless. On top of their serverless expertise, they could easily build the type of, really user-friendly APIs that that Google is building, like a Cloud Vision API. I mean, the Google Cloud Vision API, Google Trend. Right. Okay. Amazon is building out those like really simple APIs to like identify an image or something.
Mm-hmm.
Yeah. So I don't know. It's interesting, but
I guess going back to this point, it's sort of what is your core competency and what are you good at?
Right.
And if you want to go for sort of, run-of-the-mill, boring infrastructure, build on top of that, and use some of these higher-order enterprise as services, Amazon's fantastic. If you want to basically, and again, this is speaking as someone who's never built an app on either of these platforms, so take this with a grain of salt. Actually, this whole podcast should be taken with a grain of salt as someone who hasn't written a line of code in about 8 years. If you want to commit to sort of a Google way of doing things, and, if I was building a company, sure, that sounds awesome. Then the Google approach might make sense. But if you want to have perhaps a little more customizability and a little bit more pain, then perhaps Amazon's the vendor of choice in that sense.
Right. And how do you see Microsoft? Where does Microsoft take market share? I mean, as I understand, my simplistic understanding of where Microsoft takes market share is the enterprise companies that are moving from Windows to the cloud, and it becomes Microsoft already has a relationship with them. They're on Windows. It's a very natural transition. Is that the customer base that Microsoft is focused on, or is it wider?
If you spoke to me a few months ago, I probably would have said yes, that's the customer base. But to see the fundamental culture change within Microsoft around open source, around Linux, around cloud has been, pretty phenomenal. I don't think we've seen a recasting of a company in a more dramatic sense than what's happened within Microsoft in the last couple of years. You don't want to forget that there's some pretty amazing engineers within those walls up in Redmond, and so.
Oh yeah.
So I would never handicap a race and not count Microsoft as a dominant player. With that said, I think what should scare Amazon and Google is the fact that from the app layer down, Microsoft has an incredibly compelling story. Most of the world is on Outlook and Excel, and these are tools of the trade that they use. And so when they could package and subsidize these apps with a cloud platform, it's a really compelling story. And so what wasn't lost on me was the fact that I was interning for a hedge fund when I was in business school, and I was pitching I don't know if we should say this online, but a short of VMware, and it was stunning to me just how much of the world, specifically in between the coasts, was Windows Server and SQL Server, and how many of those shops were basically held captive by Microsoft. And so when I think back to how much of the world is still running Windows, it makes me think that if Microsoft is successful in transitioning even a little bit of that world onto the Azure platform, they're going to be a force to be reckoned with.
You are building a data-intensive application. Maybe it involves data visualization, a recommendation engine, or multiple data sources. These applications often require data warehousing, glue code, lots of iteration, and lots of frustration. The Exaptive Studio is a rapid application development studio optimized for data projects. It minimizes the code required to build data-rich web applications and maximizes your time spent on your expertise. Go to exaptive.com/sedaily to get a free account today. That's exaptive.com/sedaily. The Exaptive Studio provides a visual environment for using back-end, algorithmic, and front-end components. Use the open source technologies you already use, but without having to modify the code, unless you want to, of course. Access a k-means clustering algorithm without knowing R, or use complex visualizations even if you don't know D3. Spend your energy on the part that you know well, and less time on the other stuff. Build faster and create better. Go to exaptive.com/sedaily for a free account. Thanks to Exaptive for being a new sponsor of Software Engineering Daily. It's a pleasure to have you on board as a new sponsor. Yeah, definitely. And I mean, talking again about that opportunism that you articulated so well around what Cloudera can do with Spark. I mean, it's so obvious that this cloud space is just, I mean, it's like evolution from thing to thing every 6 months, Docker and then Kubernetes and then serverless. I mean, not that like people are massively adopting serverless, but the fundamental advancement that serverless offers. And we're just going to keep seeing these things time and time again. And when you're a company like Microsoft, you are positioned for opportunism.
Yeah, no, absolutely.
What about the other players like IBM, DigitalOcean? Where do these fit into when you play out the way that the infrastructure layer advances over the next 10 years? Do you have a feel for how IBM and DigitalOcean and perhaps the other smaller cloud players fit in?
So whenever I'm looking at anyone that wants to duke it out with one of the major cloud vendors, first I say good luck, but then I ask, what's your edge, or what can you deliver to a subset of customers that the big three can't? AWS is obviously the 800-pound gorilla. It moves fastest. Google is Google, has the benefit of probably the best engineers in distributed systems and AI in the world working on delivering these services and similar experiences to the modern enterprise. And then there's Microsoft, who we chatted about, and these guys know enterprise better than almost anyone else. And they have a huge Windows and Office install base to milk and transition over to Azure. So looking at any new potential rival cloud vendor, what can they deliver that's different or better? What kind of experiences will they give to developers that the big three really can't? So in my mind, DigitalOcean really nailed it. They won through simplicity, transparent pricing, and their expertise is really in marketing to developers. And they run one of my favorite blogs, and the content that those guys put out targeting their audience is fantastic. And so they've developed an incredible brand for developers, and that I believe can stand the test of time. With IBM, I'm not sure. I'm not really sure. I guess they have Watson. So anyway, I guess that might be an interesting edge. I guess the macro point here is that it's going to be the big three, and they're really sucking up all the oxygen out of the market. And so, in my mind, unless there's some massive discontinuity on the horizon that fundamentally remakes enterprise computing, I don't see how the dominance of those three big players can be challenged. Now, to get back to your earlier point about serverless and what's next, to me, serverless really signifies the conclusion of the first wave of software development as we've known it, and it's giving rise to the second, which is all about AI, or sort of this idea of real-time distributed intelligence. So hear me out. Here's another theory. But sort of back in the 60s and 70s, to write a program, you needed to be an expert in processors, compilers, operating systems. Then you had a couple companies like Microsoft came around and abstracted a bunch of that complexity with operating systems. Then in the 90s, you had the rise of Java and object-oriented programming and application servers, and suddenly app development arrived in the enterprise. Then in 2000s, software development was further democratized through cloud computing, things like Ruby on Rails, Mongo, where literally anyone can, over the course of a month, go learn how to code and be a pretty facile developer. And so now, sitting in 2017, we're arriving at this serverless world where the logical atomic unit of compute becomes a function. And so what that means really is when you know how this unit of compute behaves, you know exactly what it's supposed to do, you can start stringing together these daisy chains of functions and build pretty sophisticated workflows and apps. So in this world, the world we're coming to really is that any business analyst can write sophisticated apps at apps that scale with requests because a lot of these because these distributed runtimes are actually built on top of AWS and Google. So concurrently, sort of what's happening is that all the hard algorithmic work, a bunch of sort of the core compiler and processor things that were happening in the 60s and 70s. Are now actually, we're seeing a renaissance and resurgence of that, and so in the halls of universities and across bigger organizations like Facebook and Google, and all this research and development really has to do with AI. And to me, this is sort of the second generation of software, and which is all about building these intelligent systems. And we hear a lot of people talking about AI as this fundamentally new architecture, and what that means is that the infrastructure that supports these systems will be different. Sure, it'll borrow a lot on the innovation of this previous cycle, but also a lot of the building blocks will be fundamentally different. We're already seeing different processors, compilers, languages, frameworks, model serving systems that are purpose-built for these AI workloads. Again, the model for the future is Google. And if you look If you want to see what the rest of the world will look like in 5 to 10 years, you look at Google. And so today, you look at Google's data center, and they have a bunch of workloads that obviously run on traditional CPUs. They've got a bunch of ML, AI-oriented workloads that run on GPUs. But now they also have this thing called the TPU, the TensorFlow Processing Unit, which is a special purpose-built system on a chip for training and serving machine learning. And it won't be long until new systems and platforms emerge that support intelligent software of tomorrow. And I think that's ultimately what I'm most excited about and looking out for.
Yeah, I just did a show with Peter Levine that airs today from Andreessen Horowitz, and he was talking about this vision he has where computing gets distributed into self-driving cars and the drones, and basically these are the data centers of the future, and so everything just gets distributed among these, and then the job of the cloud server gets relegated to data-intensive training because you get the low latency responses from the data centers that are sitting in the self-driving car sitting outside your window rather than having to make a bunch of hops to an actual data center. And he was describing just how this movement of computers everywhere and into a peer-to-peer network system, together with the pressures that machine learning puts on our current model of server architecture, together will push us towards something that looks much different than what we have today. And I think you alluded to that. I do enjoy talking to VCs about infrastructure because they have a different type of skin in the game when it comes to opinions about technology. Because, if something new comes out, open up Hacker News and you're an engineer, you can tinker around with it for a while. It doesn't really cost any money for you to tinker around with it. You can build a little project with it. A VC has to put money where their mouth is if they think something is cool, and they have to project how that thing will look against the environment as things evolve into the future. And it's like, there has been this massive explosion of podcasts by venture capitalists, and some of them are not that great, but other ones are pretty entertaining because a lot of times they have to project themselves into the future and talk about computing in the future, and it's fun, it's fanciful, it's futuristic, any other adjectives that begin with an F. Explain your investment thesis when it comes to putting money into cloud native technologies.
Yeah, well, look, so I'm now at a fund called Amplify Partners, which is, dedicated to working with technical founders that are solving some of the most complex challenges across enterprise infrastructure, security, other emerging enterprise technologies such as AI. And so at this stage, certainly you have to have a directional sense of where the world is going and what it's going to look like. But at the end of the day, you're just trying to find, extraordinary entrepreneurs who are convicted enough to actually give their life to a problem that they're solving. So, if I was a growth stage investor, I'd say, yeah, I have a directional sense of what the stack of 2020 is going to look like. Now, maybe I'm taking a pass on the question, but I say I defer to the guys that are, in the PhD program at Stanford or Berkeley and are working on problems that are 10 years out. And so going and talking to them, thinking about the world, how they're seeing it, that's core to the investment thesis. At the end of the day, I definitely agree with guys like Peter who say that, computing tends to evolve and it tends to ebb and flow between centralized and distributed. The moment you start thinking you're at the end of an innovation cycle, another shoe drops and things open up. I think the most important thing as a VC or as an investor in general is just to keep an open mind and to be people oriented and to have them guide you.
Does the cloud native space feel over-invested in right now? Are there too many companies that are chasing too few customers, but the venture capitalists are willing to go after them because they're seeing things from different angles, they're seeing the expected value differently? Perhaps. Oh, go ahead.
I think at the outset of every platform shift, there's always an overinvestment period. Venture capital in general loves periods of rapid change because that's when new technologies emerge as standards, and then you have entire new value chains organized around them. And so you get, these winner-take-all or winner-take-most companies emerge. So at the outset of any tech transformation, you naturally have a lot of smart people that are trying to fill gaps and position themselves to be these winner-take-all platforms.
I'd say now, if you talk to investors, there's certainly an apprehension around cloud native. A lot of it has to do with the apprehension that's inherent to open source and just in general infrastructure. There's these two giant deflationary trends that have their paws all over IT, which is, AWS and other cloud vendors and open source. They're drastically driving the price down of all infrastructure technologies. So you have that as a backdrop. Around cloud native specifically, I'd say, there was a platform company, Docker, and then there's a platform project called Kubernetes. And then so there are companies that are trying to be sort of a Red Hat for Kubernetes or sort of co-opt that project. I don't mean co-opt in a negative way. And so, inevitably there will be money to be made. Will there be a VMware in this space? I don't know. Does Docker have a chance to be sort of a GitHub or Atlassian type company? Absolutely. And then there's going to be value to be made around, around deployment, around management, as there always is, around storage and networking. I think with every abstraction layer you move up, the opportunity to sort of extract value and build a larger value chain around yourself gets smaller because it gets abstracted further down into the platform. And so with serverless, we're seeing a bunch of companies that are offering, functions, lifecycle management. And so again, like I always ask these companies, what do you do that the platform vendor doesn't? What workflow do you enable that doesn't exist today? How can you build a standard around that workflow? And to me, these are the fundamental questions. What sort of new behavior do you enable that doesn't exist today? How do you shift the paradigm in your favor? Because if you're just tagging along, I'd say, you're sure you could build something successful. Will it be venture scale? Probably. I'd say I have doubts.
I mean, the deflationary trends are interesting in that, maybe you see less, for a given company, you see less capital going directly into something like infrastructure because AWS, the deflationary trends of that. But at the same time, if it opens up the budget, and I think you're seeing this, when it opens up the budget, companies are more liable to just purchase, if they see anything, if they see some APM tool that saves their developers a little bit of time, that time translates so easily to money because the developer's time is so valuable that they just purchase it instantly. And that's why, like, you look at this, that cloud native map that you made that I'll put in the show notes, you see all these tools that people do want to buy, and they've got great ARR properties. A lot of them have a good amount of stickiness, and they save developers time. And it's like, well, why not buy these? Although at the same time, I think you make a really good point. Like, at that point, are they venture investable? Maybe not. And then that supports the further trend of the breaking down of the wall between seed investing and venture investing, because if something is not going to deliver venture returns, then you need to give it a different style of investment. And so I mean, I think it's the same thing that's happening in consumer companies where, you have smaller investments with perhaps smaller expectations, and it's perhaps a frothier environment because it's harder to tell what's going to pan out and to what degree it's going to pan out, to what degree it's going to be profitable. But yeah, I mean, so like for the past 3 years where people have been talking about this, whether you talk about it as, it's a bubble or it's a risk bubble or whatever, I've always just throughout this entire time been like, no, it's just a change in the economics offered by venture returns on technology investments.
Yeah, and just to go back to a point you said earlier around developer tools and how, the sort of tried and true thing is you can't make money selling to developers. Yes, it is difficult to make money selling to anyone who doesn't own the budget. But, in a world where software is not only core to your business, is your business, tools that sell to developers are no different than ERP. These are tools that help you run and build your business. That's right. Yeah. And so especially talking about a world where, in my thesis, if serverless opens up programming to not only, your like front-end JavaScript guy, but also guys in marketing and guys in sales, like code is going to be everywhere. And so you're going to need tools that support and monitor and make that code better or optimize it. And so, developer tools will cease to mean developer productivity, and they'll span the entire organization. So again, I think part of it is a taxonomy problem around what does developer tool actually mean. And I think the definition needs to be refined as software eats more and more parts of the organization. I mean, look, I definitely have some thoughts about this. And all of Silicon Valley is obsessed with this notion of the power law, where, you've got one company that pays for all these failures, and it's this failure culture. But if you specifically in enterprise, and when you're looking at companies that are building strategic IP, and when you're dealing with companies that have a bounded total addressable market for what they're doing, the outcome of distributions, in my mind, and some of the data backs this up, is actually much more akin to a normal curve as opposed to a power law distribution. So, if you look at the companies that have been venture backed and produced outcomes over $2 billion in the last decade, there's something like maybe 10 of them. And then maybe another in the teens of companies between 1 and 2 billion. And a lion's share of the returns are really made in the companies between sort of 100 or 200 to a billion. And by the way, the incidence of zeros is far fewer as well. So when you look at that distribution of outcomes, there's a lot of money to be made working with companies that solve a particular problem for a particular customer segment and are super successful at servicing and delivering value to those customers, as opposed to something where everyone is feeling this pain and you're servicing everyone. So that's sort of core to my belief as an investor.
So there are all these companies making the quote unquote digital transformation, whether you're talking about a company with a ton of resources like GE or maybe State Farm, or just, legacy companies like, I think insurance companies, fertilizer companies, these companies where they are finding out that they are ultimately software companies. Like maybe they're software plus, they're a software company that sells insurance, or a software company that sells fertilizer or whatever. What areas of the cloud native stack are these types of companies adopting? Are they adopting it aggressively? Are they destined to adopt cloud technology, or are they just going to stay on some on-premise thing in perpetuity? What's your sense for how the large enterprise is shifting? I mean, do these companies just die eventually and then they get supplanted by companies that think about themselves as software first?
I don't think so, because at the end of the day, what's missing, or what's not missing, but what's critical in building any business is deep domain expertise of your customers, your vendors, everyone in the value chain. Software at the end of the day is an enabler. It's a distribution model. It's how you deliver your value. It's how you instantiate value, but it's not like the relationships you have in business, I think supersede software or the delivery of software. So I think in a vacuum, like you have a company that's software oriented, that understands the value of going cloud native. That means they could deliver software faster. That means their application's more resilient. That's what it all translates to at the end of the day. Like cloud native for cloud native's sake is a waste of time. Cloud native for having an application that's more resilient, so you're not Delta or United that grounds multi-million dollars worth of flight because you have a computer error, and cloud native because you can deliver faster and innovate faster than your competitors. That matters. So there's a business value associated with all of this. That's why it's important. It's not important because you're an ops guy and you're excited about Kubernetes and like, hey, look, we're running Kubernetes, but none of this shit works. It matters because like there's actual business value associated with all of these technologies. And so what we look for, zooming outside of the cloud native ecosystem, what we look for when we talk to entrepreneurs who are operating application companies or building a SaaS company is, do they understand the ramifications of CI/CD? Do they value being able to deliver more and faster than their competitors? Do they understand the value of actually being first to market? And that's how all these things translate into actual business value. So that's what's critical here. It's not the fact that you're using the latest and greatest technology. It's the business case for all this stuff that matters. And that's why it's important for not only VCs, but everyone to understand what's out there and understand the infrastructure stack that you're building on top of, understanding how it evolves, and understanding what you want to accomplish. Again, like the most important takeaway is, I had the fortune of working with the guys at Datadog very early back in 2011. And when I talk to them now, I ask them like, why have you guys succeeded? While a bunch of monitoring companies have since either struggled or failed? And they say, we haven't written a line of code that was anything more than our customers actually derive value from. And at the end of the day, it's all about building value, understanding what value you're bringing to the table, and capitalizing on that. So to me, that's why all this stuff is important. It's not important in and of itself. It's a means to an end.
Okay, I think that's a great way to conclude. Lenny, thanks for coming on Software Engineering Daily. It's been a pleasure talking to you.
Thanks so much, Jeff. It was a lot of fun.
Okay, great. Yeah, I really enjoyed this. A few things before we go. If you like the music on Software Engineering Daily, you might like my most recent album called Commodity, which features a lot of the songs that air on this podcast. My artist name is The Prion, that's Prion. on Spotify, Apple Music, and Amazon. Also, Software Engineering Daily is having our second meetup, March 9th at Galvanize. You can find details on our meetup page. And finally, we are about to post our second listener survey, which is available on softwareengineeringdaily.com. This is your opportunity to have your voice heard and let us know how we can improve. This data is super valuable to us, and we look at every single response. So please take the listener survey at softwareengineeringdaily.com. Thanks for listening to all these announcements. We'll see you next time on Software Engineering Daily.